Okay, what I want to do here is more practice balancing solution redox equations, and we're utilizing the acidic method. So like in the last video, I've got our steps over here on the right side of the screen, and I have a new equation. And in this equation, what's going to happen is we're going to react dichromate with chloride ion to produce chlorine gas and chromium plus 3. So again, this is an oxidation reduction reaction, and the first thing we're going to have to do is split into our half reactions. You can see usually in these there's a clue because the elements tend to stick together, and what I mean by that is that the chloride is related to the chlorine, so that's probably one of your half steps. And when you inspect this a little further, you see that we're going from Cl minus to Cl2, and in the previous playlist we talked about how elements in their natural form have an oxidation number of 0. So we go from -1 to 0. So the Cl minus, I'm going to put it over here, going to Cl2 is the oxidation step, because the way that we go from a minus value to 0 would be by removing electrons. All right, and then so this is our oxidation step, and that leaves the dichromate anion linked to chromium plus 3. Now, like in the last video, we were able to solve for the manganese ion in permanganate, and so we're going to just take a second and do that here so I can prove to you that this is actually the reduction step. So there are going to be 2 CRs, all right, and then our oxygens are -2, but there's 7 of them, so that's going to be 14, -14, and we set the whole thing equal to -2. All right, so solving, you're going to see that the chromium is equal to +6. So we're going from +6 on the chromium to +3, and the only way that can happen is through reduction. All right, now like I said in the last video that was done on the permanganate, I like to take the half reaction, which is reduction, first. But you know what? It doesn't matter, and the viewer should do whatever they're going to be comfortable with. So we're going to start with the reduction step. The first thing we do is separate into half reactions, so we're done. The next thing is we're going to balance non-O atoms, and that's kind of why I picked this particular solution equation to work with, because it's got more complex stoichiometry in it. We see that there's 2 Cl's here, and in this case we've got 2 chromiums. So to balance the chromiums, we're going to need to have a 2 right here. This is a very important step. Like I said in the last video, the viewer really needs to have these steps memorized to an innate level. You need to just be able to, this needs to be an automatic response to doing these problems. All right, so now we've got our non-O atoms balanced. So now we're going to balance oxygens next, and we do that by adding water molecules to the side without the oxygens to balance them up. So this is going to be, all right, how many we need? We need 7 H2Os. 7 H2Os to even up the oxygens here. The next step is the hydrogen issue. Now that we added 7 H2Os on this side, we got 14 total. So we're going to add 14 H pluses to this side. All right, and now the last thing is my charge balance. If I add up all the positive charges on this side with the negative charges, we're going to get +12. And on this side, we're going to have +6. because we've got 2 chromiums, each of them's worth +3. 2 times +3 is +6. Emphasize this a little bit in red. So the way that we're going to get that charge reduced on the left side here to the same charge as on the right is I'm going to add 6 electrons to the left side of my equation. And at this point, we're done with the reduction end of things. All right, so let's slide up here now and deal with the chloride and the chlorine. Again, the first thing that we're going to do is balance non-O atoms, and we see we've got 2 Cl's on this side. We're going to need 2 on the other, so it's going to be 2 Cl minus going to Cl2. All right, so those guys are balanced. Now, the next step is to balance O's using H2O. Well, there are no O's, so we skip. The next step is to balance H using H pluses. Well, there are no H's to deal with. So the last thing we got to do is deal with balancing charge. So we see on this side of my equation, I have -2 total charge, and over here is 0. So we're going to add 2 electrons to this side of my equation. All right, and now we're ready to bring the 2 equations together. But I can already see that we got an issue, see, because we've got 6 electrons over here on this side, and we've got 2 electrons for this one. All right, so what we're going to need to do to even these guys up is we're going to need to multiply this bottom equation with a 3. All right, and that will end up balancing our electrons. So now I'm going to rewrite the whole thing so we can see how it all fits together. All right, so we're going to have 6 electrons, 14 H pluses, the dichromate molecule, chromium 3 or chromium plus 3, and our 7 H2Os. All right, and underneath this now, we're going to have 6 Cl minus going to 3 Cl2 plus 6 electron. All right, and now we check the electrons out and they cancel out nicely. Remember what I said in previous videos, that if the electrons are not canceling out, you're going to have to go back and find your mistake, and most likely it's going to be in the charge balancing step is generally where it's going to be. And in a problem like this, it probably arose because of balancing the non-O atoms. If a student forgets to do that, you're going to end up finding out about it down here when the electrons don't balance. So let's rewrite this. And I think I got everybody. I think I have everybody. All right. Now, you can always double check to make sure you're correct by adding up the charge on both, the total charge on both sides of the arrow. And very quickly you see 14 and minus 2 is 12, plus 12, minus 6 is plus 6, and then on this side we've got 2 times the 2 chromium plus 3s for a total of plus 6. So this is the correct equation.